Gemma 4 ships with a 256,000 token context window, native multimodal vision, and reasoning scores that compete with models 3 times its size. But the benchmark scores hide the most important detail of this release. Google shipped this model under a true Apache 2.0 open source license. This comparison matrix shows exactly how unusual that is. Meta's Llama 3 restricts your monthly active users. Mistral forces you into separate commercial agreements for different model tiers. Gemma 4 carries none of those limitations. You can fine-tune the weights on proprietary data, embed the model directly into a product, and charge your customers for it, without owing royalties or hitting an arbitrary legal ceiling. Google removed the legal roadblocks for AI startups. The friction of deploying enterprise AI is now entirely a matter of hardware physics. When you operate under an Apache 2.0 license, you drop the cloud provider middleman. You own the model, which means you are fully responsible for hosting the infrastructure. If you provision a model with a parameter count larger than your available video RAM, your system will crash before you generate a single token. Conversely, if you aggressively compress a model just to save memory space, the reasoning degrades. The AI will start failing basic coding and logic tasks. Google engineered 4 distinct architectures for this release, scaling from a 2 billion parameter edge model up to a 31 billion parameter dense model. They built this variety to solve the sizing problem. Success with Gemma 4 comes down to selecting the exact model variant that fits the silicon you have available. The first deployment path targets constrained hardware. This includes mobile phones, IoT devices like the Raspberry Pi, and standard laptops without dedicated GPUs. On our decision tree, this hardware profile leads directly to the E2B and E4B model variants. The E stands for effective parameters, using per-layer embeddings to keep active memory low while processing native audio and delivering fast text generation. You will face strict limitations. If you push too many documents into the prompt at once, you will max out your system RAM. You must keep your context windows short. To execute this deployment, pair the model with a Llama. You can install the framework and spin up a functioning local API and chat interface in under 5 minutes. Understand that this is a prototyping environment. A Llama lacks the concurrency optimizations needed to serve multiple users simultaneously in production. You're trading complex reasoning ability for zero-cost, rapid execution on consumer devices. Our second path assumes access to a single enterprise-grade server GPU, like an A100 or H100. Following the flowchart, a single enterprise GPU pairs best with the 26 billion parameter Mixture of Experts variant. A Mixture of Experts architecture divides a large neural network into smaller, specialized subnetworks. When answering, it activates only 4 billion parameters. You get the reasoning power of a massive model at the speed of a tiny one. The hidden cost here is idle memory. Your server must possess enough video RAM to hold all 26 billion weights simultaneously, even if using a fraction of them. To handle heavy production traffic, you will wrap this model in VLLM. This creates an OpenAI-compatible API that efficiently queues and routes concurrent user requests. VLLM requires custom server configuration, dedicated cloud hosting, and strict Linux management. This combination strikes a highly practical balance. You get high-end intelligence without incurring the latency or financial burn of running a dense enterprise cluster. The third path is built for dedicated dual GPU workstations and heavy enterprise cloud environments. This top-tier hardware allows you to run the uncompromised 31 billion parameter dense model. Running this architecture at full precision requires splitting the workload across 2 80GB GPUs. If you need to squeeze this model onto cheaper consumer hardware, you can apply 4-bit quantization through the Transformers library. That compression permanently strips out nuance. You will see a measurable drop in accuracy on complex coding tasks and logical math. You have to make a direct choice here: absorb skyrocketing hourly cloud compute costs, or intentionally degrade your model's intelligence. Let's translate these options into a strict decision framework. This scorecard outlines the final strategy. If you are a hobbyist testing locally, pull the E2B or E4B weights and run them through a Llama. If you are a SaaS founder with a single GPU, pair the Mixture of Experts model with VLLM to serve production traffic. And if you are an enterprise researcher requiring raw power, provision a dual GPU cluster and load the 31 billion parameter dense model. Because Google shipped Gemma 4 under the Apache 2.0 license, you have the legal clearance to pursue any of these deployment strategies commercially. You have the model and you have the permissions. The only variable left is matching the weights to your machine.